All right, this is part 2 of lesson 3.2 for Math 1 on finding area. And our next figure, we're going to have a trapezoid. And boy, this equation looks a little bit different. We have a B1 and a B2. That's because we have two different bases. You have a top base and a bottom base. And then once again, we don't have a height drawn because these are not straight up and down, so neither of these can be the height. So we'll just put a B1 up here. Actually, I'm going to put it on the inside. We'll call this B1, knowing that this is our top base, and then B2 represents our bottom base. And so the reason they do this is because they don't want to come up with two different names. They're both bases. So we do what is called a subscripted variable. Subscripted. And you use that when you have more than one value. You're using that letter more than one time. So you have more than one instance of the variable. Variable, sorry, I forgot the L. And so if I said, oh, the base is 3, you're like, well, which base? Well, now you know which one. If I say B sub 1, so we say B1 is said, we say B sub 1, and then B2 is said B sub 2. And that means if I say B sub 1, that means I mean this base, and if I say B sub 2, then I mean on this base here. Let's go ahead and draw height. So we're going to have to do our best job here. Probably what I'm going to do here is try and line up this ruler so that this edge is even with the top base. This should give me a pretty good 90-degree angle to draw straight down on, so that I hit that at a 90 degree. And then if I want to come over and finish that off a little bit so it looks a little bit better, a little darker, easier to read. There we go. So this is going to be our height. And so those are the three measurements we're going to need. So let's go ahead and start by measuring our bottom base. And so for this one here, we're going to stick with centimeters. All right, so this one here, start here. So we're at 7. This would be 5 tick marks, 7.6. I think that's 6 tick marks here. So I'm going to put 7.6 centimeters for the bottom. One thing I found trying to measure the top with the slanted lines, I find it very distracting and hard to measure exactly a distance. So you can turn the paper over so you don't have those lines in the way, and then measure the top from this side. So I found that much easier if you find the other lines distracting. So this is 5, that would be 9, that would be 8. Boy, I'm seeing 5.8. I think 5.9 is 5.9 is way too far. So 5.8 for that one. So at the top we'll put 5.8. Please notice when I'm labeling these, I'm putting the numbers in the middle. I never try to put lengths like at the corners, because then people won't know what you're talking about. Like, what are you referring to? So whenever you're putting the measurement of a side, you want to put it pretty much in the middle of that side. Let's go ahead and get the height. That's the last measurement we're going to need. So we'll line that one up here. And so there's 3. Feel pretty good about that. I think it's closer to 3.6 than it is 3.5. Yeah, I feel much better about that. I kind of realigned this top one. So yeah, let's call that 3.6. So we'll say that this is 3.6 centimeters. So once again, H is going to be our height. B1 is our top base. B sub 2 is our bottom base. And now that we have our measurements, we can plug it in the equation. So 1/2, our height is 3.6. Our top base is 5.8, and our bottom base is 7.6. I typically do not write the units when I'm doing the math. I think it just overclutters it. I will write my units when I'm done. Now, what do I do first? Well, that's why we have order of operations, right? We're going to go to our parentheses. We're going to combine what's in there. So our 5.8 plus, 5.8 plus our 7.6. That is a 13.4. And the only thing left to do is all multiplication. So we can take our 13.4 times our 3.6 times our 1/2, which I'm just going to put a 0.5 in, and we'll get a 24.12. And that is going to be centimeters squared, because that is area. Okay, check something really quick. Good. All right. Our next problem, we're going to have a circle, and with the circle, I'm going to have to draw a line from the center to the edge, because this is going to be our radius. The radius is the distance from the center of a circle to any edge. You don't have to draw it in the same direction. Go to any side. It should be the same measurement. And that's actually the only variable that we have in here. So radius, and we talked about this before, pi is about 3.14. I'll make these wavy. So we're going to use 3.14 for pi. And we're going to have to measure this radius. So go ahead and measure the radius in centimeters, and go ahead and write down its value. Are you getting 2.0 centimeters? It looks pretty darn close to 2 centimeters to me. I don't think it's closer to anything else than 2.0. And I do the 0.0 just to say that this is rounded, right? This is the measurement, so I rounded it, saying, hey, it's probably closest to 2.0 than anything else. All right, now we go and plug and chug, plug in our numbers, and then do the math. So pi is 3.14. That's what we're going to use for it. It's close enough. And then for the radius, we're going to use 2, and that'll be 2 squared. And now we'll go and do the math. 2 squared is 4. And then now you're going to have to multiply the 4 times the 3.14. 12.56. So that is the area of our circle. And that means 12.56 square centimeters, just like we talked about in the first part of the video, will fit into here. Now this is round, right? So I find it's kind of interesting, we were talking about squared units in a round surface, but if you could, fit those squared centimeters in here, it would fit 12.56 of them. I guess you'd have to chop them up really small and then pour them in like sand to get it to fit. But all right, last problem. Okay, so what we have here is a circle and a square, and we're supposed to find the shaded region, which is these little sections here. And so how do you think we might do that? Well, I think a good place to start is let's figure out the area of the figures we have. So we have a square and we have a circle. So let's write down square and circle. And for the square, we just measure the side. So I'll do that real quick. So hopefully you're doing the same. And I'm just going to check the other side just to be sure it's consistent. So I'm going to measure down here as well. Yep, so I'm getting somewhere between 9.4 and 9.5. I think it's closer to 9.4. So we're going to say the side of the square is 9.4. And the area is s squared, isn't it? So it is 9.4 squared. So all we have to do is plug that in our calculator and we'll know the area of the square. 9.4 squared, 88.36 centimeters squared. Nice. Well, what about the circle? Well, one thing we could do is try to find the center of the circle. And one way you could do that is if you drew diagonals. So you went from this point here to this point here. I'm trying to be as close as I can right on that. And then I would just draw a line across. And then I would draw it the other way from diagonal to diagonal. This is probably one of the best ways to find if you have a situation like this. The square really does make this handy. Where if we draw that, we should have a pretty good idea where the center of the circle is now. But the reality is we don't even need to do this. Because the distance across the circle, the diameter, is the same as the length of the square, which means the distance from the center to the edge should be half of this 9.4. So if we do 9.4, nope, didn't want to do that. Divide it by 2, so we cut it in half, 4.7. We should have a radius of 4.7. I don't want to do that. Let's not put it there. Let's draw it here. So we'll just draw it over, and we'll say this is 4.7 because it's going to be half of this distance all the way across. So now we can find the area of the circle by doing pi times 4.7 squared. And remember, pi is 3.14, but let's do 4.7 squared first. That is 22.09. So it's going to be 3.14 times 22.09. So let's multiply that times our 3.14. And that's 6936. 69 point, it's 3626. But let's be honest, our answer is not that accurate. There's no way. In fact, I would say this answer isn't that accurate because we're measuring with the ruler. I think one decimal value makes sense here. So I'm going to use 88.4 as my value for the square. That's probably more of an accurate because I rounded. And here I would do 69.4 centimeters squared for the area of the circle. We'll just round it to one decimal place because our measurements were only accurate to one decimal place. Well, now that we have the area of the square, I should not box this one in since it wasn't our final answer. We have the area of the square and the area of the circle. How do we find the area of the shaded region? So if you thought, well, this is blank space, right? This area of the circle has been taken out of the square. So if I take the area of the square and I subtract out the area of the circle, whatever's left over should be these shaded areas totaled up. So we'll do an 88.4 minus a 69.4, and I get 19. So the area of those sections should be 19 centimeters squared. All right, that is the end of lesson 3.2.